Hello, everyone. My name is Uchenna Mgbaja, and I am a machine learning engineer and educator with experience spanning engineering, project management, applied machine learning, and systems design. And my focus isn't just on building models, it's on building machine learning systems that actually work in real world environments. It was inspiring to hear the work that you've been doing at EnviroCast. So this is typically the kind of work that we build. So that means thinking beyond algorithms to problem framing to dealing with messy data, looking at deployment constraints, monitoring how the models are performing in production, and basically long-term sustainability. I recently hosted the Edmonton's NASA Space Apps Challenge. I believe that's where Carvin got in contact with me. This is a global hackathon that engages over 90,000 participants annually. That experience reinforced something I deeply believe. Building is important, building in this space, but building responsibly and sustainably is even more important. So I've worked on multiple community-based machine learning projects, some of which have been published through the Statistics Canada Data Science Network. I've also designed education-driven AI systems and deployment-focused applications. And over time, there's one question that has stayed with me, and that is, why do so many technically sound machine learning projects fail once they've been deployed? So that's what today's talk is about. Right, so before we dive in, I want to quickly outline what we'll be covering today so you know exactly where I'm headed. I will start by grounding the conversation in why so many applied machine learning initiatives or AI initiatives struggle to scale beyond pilots, even when the models themselves work. So I'll briefly walk you through some of the common process approaches that project teams use today and how they differ in practice. From there, I will spend most of my time on the framework called CRISP DM. I'm not sure you've heard about it, but this is what I'll focus on because this is the framework that I use. I would also show you how CRISP DM naturally connects to deployment, operations, and real organizational constraints. So it doesn't stop at experimentation. And finally, we'll wrap up with practical takeaways, some of the projects that I've worked on where we applied CRISP DM. And my goal is that you leave with a cleaner mental model for designing machine learning systems that actually work in practice. All right, so let's look at this quote here. This recent research coming out of MIT and industry partners show that the vast majority of generative AI pilots, mostly generative AI projects, inside organizations never make it to full production, right? So you have a brilliant pilot, but once it's deployed, there's always something that kind of makes the entire organization decide, okay, maybe we need to shut this down, maybe we need to optimize. So the models might work very well, but in production, when it's deployed, typically you see a lot of failure. So teams build proofs of concept, they build MVPs, they have brilliant demos, but they struggle to move those solutions into reliable, scalable systems that fit within real organizational constraints. And when I say constraints, I mean things like, bureaucracy, ownership, governance, data quality, risk, even cost, and sometimes trust. So in other words, these initiatives don't fail because of the modeling or the brilliance of the modeling, they fail at the process stage. And that's why frameworks matter. Frameworks help teams build slow, but at least when you deploy, it has sustainability. So you move beyond the pilot phase. Right, so CRISP-DM is one such framework. This actually means cross-industry standard process for data mining. Sometimes it's shown as CRISP-ML when we're talking about machine learning projects. Sometimes you could see CRISP-MLQ, the Q is for quality assurance. Now, the key thing I want you to remember from this framework is that the goal or the vibe is to measure twice and cut once. If you look at the framework, it starts with business understanding right here, and then it goes on to data understanding. So business understanding is basically when you have a conversation with the project owner or the client partners, the domain experts. They don't have to be technically inclined, but they do understand the field that they work in. So you have conversations with the client to better understand what is the solution I'm trying to propose for this client. And then you go into data understanding. You can see that this process is iterative. So you could go back and forth from data understanding back to the client to say, okay, is this the solution that you would like to see? And then once you go from there, you go on to data preparation, preparing the data, processing the data, and then to modeling. Of course, these two are iterative, as you know. And once you're done with modeling, you go into evaluation and then deployment. But the entire process is iterative. And you can see that everything still circles back to business understanding, which is going back to the domain experts to validate the solution. All right, so before I go deeper into CRISP-DM, I want to briefly acknowledge that there are other frameworks, there are other data science and machine learning approaches that teams commonly use in practice. So for example, there's the ASM-DM, which is IBM's evolution of CRISP-DM. And this extends the original methodology with more attention to things like infrastructure, to cloud-based infrastructure. So it's particularly useful where you have enterprise environments, web platform and operational concerns are front and center. Then there's SEMA. This was developed by SAS. This is much more tightly focused on the technical modeling process. It assumes the business objective is already well defined, so there's not a lot of client conversations. The goal here is to just build out the model, and you can work it, at least the core thing here is the statistics or the math behind the problem. And then there's TDSP. This is from Microsoft. TDSP actually focuses on team collaboration, version control, accountability, having a structured template. And what's important to notice is that each of these approaches solves a specific problem, right? So the first one was infrastructure readiness. The second one was statistical or mathematical rigor. And then the third one focuses on team collaboration, version control, and the like. So knowing that there are lots of frameworks and trying to figure out which is the right framework to use for my particular applied setting is essentially what ensures that the project is scalable and successful. Another critical set of practices I want to briefly touch on is MLOps, which is machine learning operations. This shifts the mindset from treating machine learning as a one-time project. Instead, you treat it as a living system, right? Because unlike traditional data science workflows, MLOps assumes that the model will decay, meaning that you deploy the model, there could be data drift. So a model that was performing at maybe say 90% accuracy, if that's the metric that you're looking at, for example, could all of a sudden start performing at 50%. So it has to be monitored. It emphasizes, things like continuous integration, continuous deployment for that system, right? Then there's Google's MLOps maturity levels, which describe how organizations evolve from, having the manual system to ad hoc deployments to automated self-healing pipelines. So these levels help teams understand where they are today and what capabilities they need to deploy scalable models. With Google's MLOps levels, it actually assumes that the right model was already built for the right problem. So the core goal here is keeping that model alive in production. So that means things like ensuring that you have optimized infrastructure, ensure that the automation works and is self-healing, and then you also ensure that you have monitoring and that leads to reliability. So the last group of approaches I'm going to look at is Agile methodology or Agile data science. These are typically project management frameworks, and it emphasizes shipping small or shipping out that MVP and then fixing it later, right? So this can be extremely effective in environments where speed and experimentation are the core goals here. So particularly for startups, you would want to ship out that MVP so that you can get funding, and then you can fix it later and optimize infrastructure, decide what cloud-based platform to use and the like. And then Scrum, while it's not specific to data science or AI, is widely used to manage the work itself. So many teams use different variations of these. There's sprints, there are stand-ups, looking at backlogs and the rest of them. But within the CRISP-DM methodology, it's important that you have some sort of framework or some sort of structure, which is where Scrum comes in. So Agile and Scrum are like delivery and coordination mechanisms, while the CRISP-DM is the framework that you need. So Agile and Scrum help you to execute the actual work. So just looking at all of these frameworks that I've mentioned in total, so if you look at each of them, like I said earlier, it actually links to a specific purpose or core outcome that you're looking at. Each one is optimized for a different problem. So CRISP-DM works best in enterprise environments because it forces your team to slow down, to clarify the problem, to have a conversation with the client, and then align with the business before building anything, right? Because sometimes the client doesn't even know what the solution they want, right? They just know they have all this data and they want some AI solution. So there has to be a core understanding and alignment of the organization. And then TDSP shines in collaborative, code-heavy teams because it emphasizes things like collaboration, version control. CIMA is more optimized for statistically driven work. MLOps is for, you already know what model you intend to build out. So this is mostly for keeping the model alive, right? Monitoring, retraining, and automation. And of course, Agile and Scrum are basically for ensuring that you have structure within these frameworks. All right, so I'll go back to CRISP-DM because this is a framework that we use. CRISP-DM was developed in the late 90s by a consortium that included SPSS, NCR, and Daimler Chrysler, not as an academic exercise, but as a practical response to how data projects were failing in real organizations. So what's important is not its age, even though age is typically what you use to measure how successful a framework is. So if you think about some of the business frameworks that SWOT, PESTLE, those were actually developed in some Ivy League colleges like Stanford. And the judgment of the validity of these frameworks is how long they've stood the test of time. So CRISP-DM has been around a long time to be trusted. The methodology is comprehensive because, like I said earlier, it starts with business understanding all the way through deployment, and it puts problem framing and evaluation front and center, right? So it's not the complexity of the model or the brilliance of all of the data processing that is done that is the core focus here. It's getting the solution that is aligned with the client's need. That is the core focus of CRISP-DM. So there's a lot of experimentation that goes on here. So, and it's intentional because in real world application, learning often forces you to revisit the initial assumptions you had early, right? So you could build out an entire solution and test it with the market and realize, no, the market is not interested in this particular feature, which is the problem that CRISP-DM solves because it gives teams permission to restructure and reinvent and come back to the table. So I want to talk about some of the practical applications that we've experienced using CRISP-DM. These are some of the projects that I've worked on, some of which have been published. So for the first one, recall that with CRISP-DM, we want to measure twice, cut once. That means involvement in the project, involvement with the client, core business understanding first. So for example, the Edmonton Food Drive project, we didn't start with, give us the data, let's start cleaning and let's start, because the goal here was to figure out what part of the city had the most donations and where do we need to allocate volunteers around the city. So where do we need volunteers the most, where do we need them less? But we started by participating in the food drive itself. After having the conversation with the clients, it was a multi-stakeholder project, but we participated, we joined in those volunteers, we signed up as volunteers, figured out the entire process. How did the volunteers enter data into the forms? How was data collected? That way it was easier to do the data processing because we understood if someone said they had spent 300 hours in a particular neighborhood, that didn't make sense. That was probably an error, right? So the real goal wasn't just prediction because we already had access to the data. The real goal was logistics optimization, right? So understanding the pain points from the volunteer side of things, and then also going back to the leaders and figuring out what is it that the solution could be, right? So that understanding led to a very specific design choice because we built out interactive maps, which was one of the solutions, which was not particularly machine learning because interactive map was just basically converting the PDF maps that they had into an interactive map that was within an application. And then within that application, there was a data collection process as well that was linked to the prediction for, okay, how many bags will be collected per neighborhood, right? If we had gone in as if this were a core machine learning project, that would have been the only solution we had, predicting the number of bags collected per neighborhood, right? But just because of that involvement with the client, there were multiple solutions that were aligned with what they wanted to do, right? Then the other project was the housing analytics project. So this one was to predict rental prices for underrepresented communities within Canada, so particularly in Ontario. So the goal here was because for those smaller communities, you typically do not see information about rental prices online with the Google search. So they wanted to provide that information for these smaller communities. And part of the business understanding for this project was to not only have a project kickoff meeting with the client, but to attend AGM meetings with them. We listened to, the housing challenges that were being experienced, how people were actually getting this information, and that shifted the project from a generic model that can predict the price of rent to a decision support tool. So the application that was built now included things like proximity to schools, for example, proximity to the hospital, and did that affect the price of houses in that area, right? And this was because we had that conversation with the client and then realized that people were making those choices, not just based on the number of rooms, which is typically what would happen if you had the data set. The data set will show you number of rooms, does it have a studio, this is the price of the house, or this is the rent, and this is the location, right? So a typical machine learning problem will just predict based on those features. But because we had these conversations, we were now looking at things like proximity to school, is there a walkway, is there a play park near the place? And all of this became contextual information for those predictions, right? So there are other projects, but the first two have been published. Then the third one was the Birds Observatory project. The goal of this project was actually to understand, and you can see there's a diversity in the kind of project problems that we solve, right? And still the framework works regardless. So for this project, it was for understanding migratory patterns for saw-whet owls. I hope I'm getting the pronunciation, but actually the owls, the goal here was to figure out where were they going, right? So, and how far were they traveling, and did they come back, and at what season? So to better understand this, business understanding meant respecting the domain expertise. We're just listening to better understand, okay, why was this important? What information did they really need? And we participated in the late night tagging sessions. This meant that they actually caught those owls, put on tags on them. We were part of that process. I mean, for like 2 hours, but it helped give us better understanding of what the ornithologists were trying to explain, what constraints existed in the field. That context shaped everything from feature selection to how results were interpreted. The final one that I would like to talk about was the X classification. So the goal here was to actually do an image classification project, so to determine what species a particular egg came from, right? And if we hadn't had that intense business understanding, what would have happened is that we would request, images of the eggs, right? And then the number of species, and then create a computer vision model, and then do the classification or detection. But because we had that conversation with them, detailed conversation, every week we'll come back, have that conversation, build out an MVP, ask them if this is what they wanted, have multiple conversations again. We figured out that they had over 300 species in their collection, but not enough for the machine learning project, right? Not enough species. So for example, for each species, they might have just like 3 eggs, right? So they figured out that, okay, even though they had 300 species, they were only interested in about 25, right? And that actually helped with, fine tuning and cleaning out what the problem would be, right? So that insight, which only came from that direct engagement, narrowed the problem scope. It also informed how we captured the images to ensure consistency in things like lighting, in angle, and the quality of the images collected, because now we knew what their interest was. So there's a lot more projects like this that we've used CRISP-DM, and business understanding wasn't just a phase that we checked off. It was an ongoing process of immersion, observation, having a conversation, having a relationship with the client. And that's why CRISP-DM works so well for applied AI. Remember, for those frameworks, it really depends on the kind of project that you're working on. So CRISP-DM legitimizes this kind of upfront and continuous engagement, and it dramatically reduces the risk of building the wrong solution, no matter how good the model is. So what all of these use cases have in common is that none of them started with the data set. They started with questions. They started with conversations with the client, involvement in the project. Who actually owns this model? Who are you building the solution for? What action would you like to see? What prediction are you interested in? What is the cost? What would be ethical? What would be unethical, right? So this is typically what leads to sustainable models being deployed. And when teams skip this step for a project or projects like this, they often build maybe what could be considered technically impressive models, but they fail when they're adopted or when they're scaled or when they're in production, right? So when teams take this phase seriously, everything downstream first, right? Everything downstream now starts to work. So your data collection, your modeling, your evaluation and deployment becomes clearer. For the data understanding process, this is also another one that takes up most of the time. As you would know, data processing, data cleaning, this is actually one of the bulk of the work that you will do. But having that business understanding enables you to go back and forth with the data cleaning process and data preparation process. And in every project that I shared, those examples that I shared earlier, we had this back and forth, especially between these two phases, right? So for example, in the housing analytics data, we ensured that once we built out an MVP, we went back to the client, ensured that this is exactly what they wanted, the solution to look like and how the audience would actually interact with the application. So again, this is really crucial for scalability. And again, like I said earlier, once these first two are kind of fixed and then you maintain that relationship with the client as you're building, every other thing kind of falls into place, right? So modeling falls into place, evaluation, looking at the accuracy, going back to the client, deploying, going back to the client, and then ensuring that this is the solution and that they have the cost to deploy it to production. So taken together, these phases remind us that applied AI isn't about shipping a model, it's about maintaining a system. So I want to close with a few key takeaways. The first one being that applied AI or applied machine learning is fundamentally a systems problem. Models matter, but they're only one component in a much larger ecosystem that includes people, processes, data, and those decisions that they make. And secondly, most applied machine learning initiatives or AI initiatives don't fail because the model wasn't sophisticated enough. They fail because the problem wasn't clearly framed, evaluation wasn't grounded in context, or that deployment lacked ownership and sustainability. And that's why frameworks like the CRISP-DM continue to matter. It doesn't tell you which algorithm to use. It gives you discipline around when to slow down, what questions to ask, how to design the systems that survive beyond the pilot stage. And finally, frameworks don't slow teams down. They prevent expensive failure. If there's one thing I hope you take away from today's presentation, it's that applied AI succeeds when we design for decisions, for trust, and long-term impact, not just for model performance. And thank you again to the team at EnviroCast Geo for the invitation. I'd love to open it up for questions or discussion.
Thank you so much. I do believe I don't see any questions in the chat at the current moment, but the talk was very comprehensive and covered a lot of detail. I was actually quite amazed at the different structures and everything. So it was, very insightful.
Yeah, I think that we're running a little bit behind on schedule, so Kaveen can post your socials into the chat, and they can ask you questions personally if that's okay with you.
That's okay. I'll follow up with that.
Yeah, for sure.
I'm going to quickly put your LinkedIn in the chat. If anyone does have any questions or wants to know more, you can refer to that. And thank you so much for being here.
Thank you so much. That was an incredible talk. I think your experience as an educator really came through with that talk, and it really, for me at least, it helped educate me a lot about ML and AI systems. So thank you for that. Thank you for your time.
Thank you so much. There is always an opportunity to contribute to the discussions that we have at EnviroCast Geo. If you are interested in attending or even speaking at a future conference, learn more at geo.envirocast.org. We're excited to hear your insights.